Hey guys, welcome back to my channel. In today's video, we are going to see how to rotate an array by d steps to the counterclockwise direction, basically to the left hand side. So let's see what the question says. Given a unsorted array ARR of size n, rotate the array to the left, basically counterclockwise direction by d steps, where d is a positive integer, right? So if you remember, last problem we have solved how to rotate an array in clockwise direction by one step. So an array will be given, we have to rotate by one step to the right hand side. So all the elements will be shifted to one step ahead except the last element, right? So last element will go to the first index. So similarly, here we are going to do the similar thing, but not to the right hand side. We are shifting all the elements to the left hand side, right? But not by one step. We are doing d times, so d steps, right? So 1 2 3 4 5, let's say this is the array. We are actually rotating once we rotate, this 1 will go here, and then 2 will come to the first place, 3 will come to the second place, 4 will come to the third place, and then 5 will come to the fourth place, right? And then we are doing again, because d is 2, so we are doing again the same thing. So 1 which was here, it will come to the second last index. Similarly, all the indices will be shifted once again. So that's how we are going to approach this problem. So the problem is pretty simple. Let's say this is an array, and here d is given, let's say 2. So what we are going to do, we are going to shift this once. So after shifting this once, this will become something like 5 will be here, 4 will be here, 3 will be here, 2 will be here, and then this 1 will move to the last index, right? So one time is done. For the second time, if you do the same thing, this will become something like 3 4 5 1 and 2, right? So this is what we wanted. See, these two are equal. So d is there, so we have to rotate to the left hand side by d times, right? So the brute force way, the most brute force way to approach this problem is rotate this d steps. You know how to rotate it by one step, right? So repeat the same thing d steps, right? So to rotate an array by one step, you will take log n time complexity, right? So if you are doing for d times, so total time complexity will be of d into n, right? So since you are not taking any space complexity will be of 1. But I'm saying, bro, can you please optimize this? We can. How? Let's see. So what we are basically going to do, this is the array and this is the output, and d is 2. Try to observe something. When d equals to 2, see something. The first two elements, it actually went to the back side, and rest all the elements traveled two distance backwards. See, 3 came here, 4 came here, 5 came here, and these indices are filled with these first indices. So what we are going to do, we are going to basically store this. We are going to store this in some, let's say, temp array. Temp array will be 1 and 2. And then we are going to run a loop from I equals to d, I is lesser than n, I plus plus. And what we are going to do, ARR of I will move to ARR of I minus d. Then after this, we are going to iterate through this temp, and then we are going to place all these elements in these indices. So basically a loop will run from I equals to n minus d and I is lesser than n, I plus plus, Then we are going to give some pointer, let's say ptr, and we are going to store something like ar of I will be temp of ptr, and then after each iteration we are just going to increment this pointer. So that's how we can solve it in of n time complexity, but we are taking temp. So space we are consuming, space you are taking of d. So the overall complexity will be of n time and then of d space, because we are storing d elements in temp. But bro, I'm not happy with this. I'm not happy with this extra space. Somehow I need to get rid of this extra space also. So the third approach is getting rid of that extra space. So basically you're going to solve this in time complexity of n and space complexity will be of 1. Let's see how. Before that, let's observe something, right? So this is the array and this is the output. So at first what I'm going to do, d, let's say d is 2. I'm taking the first 2 indices and then I'm going to reverse it, right? So after reversing it, it will be 2, 1. And then I'm going to take the second section. Then I'm going to reverse this also. So it will be 5, 4, 3. So now I got this array and I need this. Basically, this is the answer. So reverse it once again. After reversing it, it will be 3, 4, 5, 1 and 2. Can I say these two arrays are same? Yes. So that's how we are going to solve this, right? So basically we are going to reverse this array from 0 to index. So let's give the indices 0, 1, 2, 3, 4. We are going to reverse from 0th index till the first index. Then we are going to reverse from second index, then fourth index. Then we are going to reverse the entire thing, right? So from 0th till the last index. So in a generalized way, can I write like I'm reversing from 0th index to d minus 1th index, then from dth index to n minus 1th index, then the entire array, right? So from 0th index to n minus 1th index. So that's how you will be solving this problem in of n time complexity and of 1 space complexity, right? So now let's look into the code. You might be wondering what is this. I will come to this part, but before that, this logic is same as what I have explained above, right? So why I wrote d equals to d modulo n. So let's understand this by an example, right? So here the n is 5 and this is the array, right? Suppose I am saying, bro, can you please rotate this 5 times? Then after rotating this, you will get the same element, right? And let's say I'm saying, bro, d equals to 6. Can you please rotate it by 6 times? So bro, what you are going to do? You are going to rotate it by 5 times and then you are going to rotate it by 1 time. So 5 times rotation is basically the same array. So actually you are rotating only by 1 time. So what I'm saying, whatever the multiples of 5 is there already, you don't have to rotate it, because after rotating the array will be same. So just take the remainder. So here in this case d equals to d modulo n will be 1, right? Basically 6 modulo 5 will be 1. Let's take some other example. D equals to 12. So you are rotating it by 5, then again you are rotating it by 5, then you are rotating it by 2. But bro, this is same. After this rotation also, you will get the same array. So in actual, you are rotating 2 times, right? So that's how I'm saying D will be equals to D modulo n. So that's it for the video. If you like the video, hit the like button. If you have watched till now, please write down in the comment section. Until next time, see ya.